Welcome to Field Notes, the monthly podcast of Modern Steel Construction and AISC. I'm Jeff Weisenberger, editor and publisher of Modern Steel Construction.
And with me is Rob Connor, and this is a long and distinguished title for a man with a long and distinguished career. Rob Connor is the Jack and Kay Hakama Professor of Civil Engineering at Purdue University Lyell School of Civil Engineering. He is one of this year's Lifetime Achievement Award winners, being recognized for his significant contributions to the advancement of design in the areas of fatigue and fracture and other performance and durability issues when it comes to steel bridges, and also his service to AISC and NSBA, National Steel Bridge Alliance.
Let's start with NASCC. I understand you've been going for almost 20 years. In that time span, are there any shows that stick out to you in particular or that are particularly memorable?
Yeah, the T.R. Higgins Lecture Award
Yes.
Back in 2018 was certainly a highlight of my career, because that's a recognition on the research side.
Mm-hmm.
And that's what we're all, as faculty, right? That's what we're trying to do. And the fact that AISC would say, kind of an attaboy, seems like was something that I didn't feel I deserved. When I look at the people who've gotten it, I'm honored. And another award winner, Todd Helwig, had said one time, and it really touched me, how that, and then you look at people who haven't gotten it that we look up to,
Mm-hmm.
in our careers. And so that was certainly a highlight.
Sure.
That year. Yeah.
Well, very well deserved. Let's dive back. Let's really go back a little bit in history then, and talk about how you got to that point in the first place. What got you into the world of engineering?
So I did my undergraduate work at Drexel University in Philadelphia.
Yep.
I'm originally from northeastern Pennsylvania.
Okay.
And great program there. It was a number of years ago now.
Mm-hmm.
But I started out as an electrical engineer because foolishly I thought that had to do with lighting and wiring and things like that. I like working with my hands, and it was more ones and zeros. That
Sure.
wasn't my thing. But I did take this class that most of us have taken called statics, where
Okay.
we first start learning about forces. And the professor mentioned if you go outside after class, he was talking about pins and rollers. He said, there's this railroad bridge. Take a look at it. You'll see pins and rollers. And I went out and I saw there was a train going over it, and I thought, I can see that. I can relate to that. And literally that week I switched to civil engineering and then started to focus in structural engineering.
Okay.
So that little thing that was pivotal changed me.
It's funny how things like you can take a turn just based on something that seems kind of insignificant like that. Were you in the design world for a while first, or did you go straight into teaching?
No, I graduated in 1990 from Drexel and debated going full-time, part-time, and I started work with a company. It was Griner Engineering at the time, one of those old companies, kind of privately held, which has now been bought up. But I took a job with them because they had great experience in bigger bridges in the King of Prussia area, and was taking classes part-time.
Okay.
So I worked for about 4 years doing bridge inspection, bridge design, and so forth in the Philadelphia region.
Okay. And so how did you get to Purdue?
So that's kind of a long path. I went to Lehigh for my grad work in '94. I wanted to know more about this topic of fatigue and fracture, and got some direction. Moved up there, did my master's and PhD there, and then stayed on as a research engineer. And I really enjoyed the work there. Great atmosphere to learn, especially in the area of fatigue and fracture at the time. But I did want to do more, have a little more involvement with students and teaching and so forth. And so an opportunity came up at Purdue University, who had just built a brand new, gigantic structural engineering lab.
Yep.
And so my joke is, the day I got there, it had that new lab smell. And literally it did. I mean, it was brand new.
Yeah.
And so that was back in 2005. And I was fortunate enough to get brought in over there. And then I've been there since.
Right.
Yeah.
I mean, not only did it have the new lab smell, but you're like, oh, look, they built me a new lab for my first day here.
And an old friend of mine, who we were PhD students together, another Higgins Award winner, Professor Amit Varma, had started there about a year before. So I knew Amit was there. And I thought, well, if he's there, it's got to be halfway legit. And Mark Bowman, another researcher who I knew, was there. And so there was a good base of steel people there. Judy Liu was there.
Oh, yeah.
So we had a good steel family.
That's right. I forgot. Judy was at Purdue and now at Oregon State.
Yeah, so we had a good group there.
Oh, for sure. Definitely. I do want to talk about research a little bit more. But as far as being a professor, can you tell me what that experience was like your first time up in front of a classroom full of students?
Yeah, it was a switch. I did a lot of professional training, right? At Lehigh, we did some short courses and things. The first class I did that was undergrad, where it was really on my own, I believe was a mechanics and materials class. And that was, we kind of handled it at Purdue as an intro to structural engineering.
Okay. Mm-hmm.
And so one of the things I struggled with at the time when I was a student was, why are we learning this? I don't get, this, and sometimes you wish you could go back and take a class over once you realize what was important, right?
Mm-hmm. Right.
I wish I paid attention kind of thing. So what I started to do was introduce a topic called failure of the week. That was, if we're talking about initial, early, in that part of a student's education, compression members. Well, we'd talk about, the Quebec Bridge and buckling, or fatigue, the Comet aircraft, right? So we'd always try to lead off with a failure. And I really enjoyed that, and engaging with the students, trying to motivate them to get their ideas. It was overwhelming. It was a big class. I wasn't used to that. Purdue's a big program.
Sure.
But we have great quality students, and they definitely made you feel at home. So it was a fun experience.
Well, that's good. No, great to hear. On the research side, do you remember? Well, I'm sure you remember, but can you maybe say what your first big research project was at the lab?
So my first big one probably would have been when I was still at Lehigh.
Oh, okay,
an NCHRP project, where it was that was my little baby, and that was my first NCHRP on damaged heat straightening of girders and their fatigue and fracture performance, which then, fortunately, I guess, led to a long line of other NCHRP projects that probably put all the gray hair in my head. But I've been fortunate. That would have been the big one. And then moving over to, and other ones there, but then moving over to Purdue, we've been very fortunate to land some great projects. And I would say, if I had I can't pick a project, but I guess I would pick a theme that we've worked on for probably 10, 12, 15 years on this whole trying to rationalize this topic of the fracture critical member. Right? That's been the kind of a career thing almost. And through multiple projects looking at inspection reliability, then all the behavior, system analysis, big fracture tests, and built up members and all that. So that theme, I guess, has been something I've really enjoyed. But it all started at Purdue, kind of the idea of doing that work.
Okay. Well, speaking of fracture critical, and I'm still trying to wrap my head around it because I'm not an engineer, but there was some discussion at the keynote the other day about fracture critical, and then it's the terminology, fracture critical, and then I think it was non-redundant.
Yes. NSTM, non-redundant steel tension member.
Can you talk about that a little bit, and then just the significance when it comes to infrastructure?
Yeah, I mean, that's one we're real happy with.
Can you talk about that a little bit, and then just the significance when it comes to
for the bridge industry in particular, steel bridge industry, it's a game changer, right? It's so fracture critical. It's a terrible term. First of all, right? If you get on an aircraft, the idea is, the background, right, is that you don't have enough redundancy or perceived redundancy so that if one component fails, the bridge would probably collapse.
Right.
But if you think about an airplane, the landing gear are fracture critical, right? If they fail in fatigue and fracture, the wing, that's a bad day, right?
Right.
And so if a pilot said to you, welcome to the fracture critical aircraft, you'd get off probably. But we would call highway bridges that, right? And so it's not an attractive term to begin with.
Right.
But those bridges, when they're classified that way, have special requirements in fabrication and design. But the big issue is the long-term inspection, that every 2 years, arm's length inspection. Expensive, risky for the inspectors because you have to get up close.
Sure.
Right? Closing lanes, you're risking people's lives in traffic backups, right? Unfortunately, bad things happen in traffic accidents at times. This work tried to rationalize that rather than just kind of finger to the wind, well, there's two girders, they're probably fracture critical or it's a truss. It finally now resulted in codified approaches in AASHTO that would say, here is how you can evaluate a member to really determine if it were to fail, what the outcome would be. And if so, let's really give it a lot of inspection, right? We don't want that to happen. But if not, maybe I can treat it differently based on engineering decisions.
Right.
And so we had a session here, a couple sessions previously, but now with the new law, the new Code of Federal Regulations that came out, AASHTO approved these documents in 2018, but the laws have to catch up on how we inspect. When the law came out in 2022, the new Code of Federal Regulations, it allowed us to implement that. And that's a game changer for the steel bridge industry, that we can now rationally treat these members. And what it means is we can use very efficient designs, two girder twin tubs or trusses or whatever, And we don't have to worry if a member fails. We do those analyses. We do the scenarios to verify that, those member out type scenarios. There was a nice presentation that HNTB gave, and they're using the work, right? They're doing things with it. We're using it with NDOT now. Other states, Texas is using it. And so that's really neat to see that come to fruition in the rational approach to a failure mode.
Okay, very good. And when it comes to your research, I'm guessing a significant portion of it has been dedicated to that very subject.
In various aspects, from the heavy testing and finite element analysis to, well, how reliable are we in detecting cracks? Those kinds of things. So kind of the phrase we use is called an integrated fracture control plan.
Okay.
We have intervals of inspection that are tied to what the structure can tolerate, tied to what an inspector can find, right? We go out and look for a crack, but if we can't find them, the inspection's pointless, right?
Right.
So it really integrates all that together to have a high reliability for that limit state.
Okay. Good to know. Thanks for clarifying.
Sure.
And back to the lab. Can you say what's going on right now?
So we've got, the lab is really busy. It's really a great facility. The strong floor for people who do testing is about 11,000 square feet. So it's a big testing floor, let alone then all the other space. And for scale of that, one of the things we have in there is about a 35-foot span railroad bridge, entire bridge, with ties and rail, right? We're going to be doing some testing on it, but my colleague Amit Varma has huge tests going on. I have some small pull plate tests going on with another student. He and I, we had some big bridge girders. So the work that I have going on right now is looking at kind of continuing down this path of redundancy or built-up members. We've kind of figured out the whole fatigue fracture part, but one of the challenges that owners face with older bridges is related to pack-out corrosion, when plates get bent apart. And corrosion gets in between these old riveted members, and they bend and they look bad. But nobody's really done any research into, but what's the real effect on capacity? What's the real effect on fatigue? And so we acquired some members with damage from old bridges. We created damage of our own. We figured out how to do that. And we would test these in the lab. So long-term fatigue tests and strength tests, some cold temperature tests similar to work that we did previously, a lot of finite element analysis, and then doing the same thing on the compression portion of the member, right? Well, is it going to buckle more quickly? Do we lose capacity? And again, the whole objective is when do we really need to address this problem, and then how do we get that guidance into the AASHTO spec? So that's been an ongoing one that's been a lot of fun.
Okay, yeah, that does sound like it. And speaking of old bridges and old bridge components, I want to talk a little bit about S-BRITE.
Sure.
You gave me a tour of it, and it was just a fascinating idea, concept, and it was just kind of cool to see too. And we were there on a nice day, so that helped. But can you remind me what the acronym is, and maybe just describe it a little bit?
Yeah, you bet. So S-BRITE is the Steel Bridge Research, Inspection, Training, and Education Center. Sometimes we'll say engineering, depending who we're talking to on that last D. We'll switch it back and forth. But basically, it's a large outdoor facility that we have about 20 acres. We've developed about 10 that Purdue's provided for the facility. And as I was saying, like I'm more of a tactile learner. The ones and zeros didn't work good for me in electrical engineering. So I would teach a lot of courses in fatigue. And we had some issues in Indiana on a bridge that had some cracks in it. And what we started to realize is inspectors don't really have firsthand experience with seeing cracks quite often. Most bridges don't crack anymore, but they're hard to find. It's a challenge. And what details are good, what details are bad. And so we would always show the pretty picture slide, right? And it has the obvious damage because it's the only way it'll show up in a picture. Then you go to the real detail, and I don't see anything. And I thought, boy, it'd be neat to keep a few components that have damage, whether it's corrosion, fatigue, impact damage. And pitched it to Indiana DOT. They were very supportive of it. And long story short, so was Federal Highway. A lot of other states said, boy, we'd love training where we could come see things that were taken out of service. And that's really what the main portion of the S-BRITE Center is. It's a training facility where we have, let's see, now we have 4 complete bridges.
Oh, really?
I think when you were there, it might have been 2. Lots of other components from bridges. And we want things with damage. Right? Because we're trying to train people. But if you can keep in mind, we're training bridge inspectors, designers, but then imagine if you have an undergrad steel class and you're trying to explain to them about big bolted joints. Well, let's go look at some. We have.
Yeah.
Right? Big old riveted connections. We have the only pieces from the I-35W collapse. We've erected the joint to understand failure modes and things. So it's an incredibly unique facility that is used by myself, but then other people. Someone's interested in using drones for inspection. Well, we have bridges with damage, but we don't have to worry about fall protection, traffic control, the risk to the public because it's kind of in a controlled environment.
Right.
And then a big part is our outreach of professional training, where we help DOTs with problems as well as then provide training to their staff.
Sure.
Neat facility.
It is. And remind me, what is your acquisition process when it comes to these damaged bridges and components?
That's a great question. Yeah. Well, usually we sneak out at night and try to get what we can.
Get a blowtorch, cut a piece off here and there, and then take it. Yeah.
No one knows we're fine. So generally, because a lot of people know about the center now, certainly our partner states, they will reach out to us. And they'll say, we have a bridge coming out of service, preferably in a year or two, right? If it's tomorrow, that's tricky sometimes, but a ways out. So the latest example would be Texas reached out. They have some components from a bridge and they send the plans. They send inspection reports. Is there anything that you think would be beneficial for training, research, that whole thing at the center? We'll put it in the provisions now to save that. So that's generally how it happens right now, is our partners will say, hey, we have something. But it's also any state DOT who knows we exist. They don't have to be a partner. And, I always tell people, we can always say no.
Sure.
But once it goes in the melting pot, it's gone. Right? And so if it's something that's unique, has some characteristics of something that we'd really like to be able to share with people, give us an opportunity. And generally we pay for shipping, put it on our truck, or we have a flatbed show up if the contractor can set it there. And then we just put it out in the facility.
When it comes to bringing things on this truck, you've got some larger bridges, some complete bridges. Did those have to come in components?
Some of them have come in components.
Disassembled?
Yeah. We have a 90-foot span through truss, both truss lines and all the floor beams. That came in 4 major pieces put back together. I would say, there's a lot of cool pieces, right? There's the heaviest piece, or then there's the biggest piece, right? There's different ones.
True.
I think some that the 35W pieces draw people's attention.
Of course.
But the other ones that do is we have some plate girders from the state of Minnesota that are the webs are approximately 23, 24 feet deep.
Oh, man.
Gigantic horizontal web splice. You see them from a mile away, right?
Right.
Those are cool.
Yeah.
Right? I mean, students, when they see that and realize, that's a plate girder, the bridges can be that big. They're relatively short lengths because they're so tall, but they have made an impression on a lot of people who've come through the place, just because of the scale.
Oh, sure, I can absolutely.
Everybody wants to stand on the flange and get their picture.
It's a good photo op.
It is a good photo op, yeah.
That wraps up another edition of Modern Steel Construction's Field Notes podcast. Thanks for listening, everyone.